Hello guys, how are you doing? I hope you are having a good day. So let me tell you a story. Let's start with a triangle. Yeah, and let's say this side this side is 1 and this is 1. So the question here is what is the value of this side? And let us remember that this triangle is the rectangle, I'm sorry. So according to the Pythagoras theorem, the side of this value, let's call it x, should be can be written as x squared should be equal to 1 squared plus 1 squared, meaning this side squared plus this side squared. So this will give us, because 1 squared is still 1, so we will have 1 plus 1, so we have 2 here. So x should be equal to the square root of 2. Yeah. So but there is one problem with this, is that we don't know exactly the value of square root of 2. Like, what is that? Like, how do we find that? So to answer that question, Sir Isaac Newton came up with a formula, a beautiful formula, which can express pretty well the value of square root of 2. So for those who doesn't know Sir Isaac Newton, here he is. Yeah. So Sir Isaac Newton was the physician and the mathematician too, and the philosopher too, and he found out so many great concepts in physics. He discovered gravity, yeah, and he found out so many other concepts. So what he's saying, to find the value of the square root of any number, so the square root of a, for example, what he's saying is that we need sequences to find out the square root of any number, and we should iterate by using this formula, an plus 1, an being the new value of the sequence, half of an being the previous value of the sequence. Yeah, so by using this formula, we might be able to find the square root of any number, of any given number. So to not confuse, okay, this is x or whatever. Yeah. So today in this video, we are going to solve the previous question. We are going to find the value of this, knowing that this is 1 1, and so we are going to find, at least we are going to use the Sir Isaac Newton method to iterate and find a close value to square root of 2. So here we go. This is the formula of Sir Isaac Newton. Perfect. So the formula of Sir Isaac Newton is here. An plus 1, which is equal to half of an plus 2 over an. Yeah. So let's call our sequence root. Yeah. So as said in the formula, we should have a guess, like, to find our first value. So as guess, because here we want to find out the value of square root of 2. So we want to find out square root of 2. Let's abbreviate the square root as SQR. We want to find out the square root of 2. Yeah. Using the Sir Isaac Newton method. So as a first guess, because we know that the square root of a number must be less than that number, and greater than 0, because it should be positive. So here we can take as our first guess 1, which is simply 2/2. So we can divide the number by 2 and then try to guess. Yeah. So if we take as our first number 1, then we can apply easily the formula as the first iteration. Iteration 1, the formula is here. Wherever there is an, I just plug the new value, or the guessed value, which is 1. So after calculating this, as the answer, we will have 3/2. So after our first value, we have 3/2. So right now we are going to iteration 2, but iteration 2 means that the new value of an is the last value of an plus 1. The last value of an plus 1 was 3/2. So wherever there is an becomes 3/2. 3/2. Yeah. So we should do that and so on. So basically, okay, so after the calculation, our second iteration gives us 17/12. Yeah, so we can go for our third iteration. So instead of an, it now becomes 17/12. And because this is kind of weird, let me put brackets here. (17/12). So after calculation, we found our new value being okay, let me put it in decimal. 1.4142156686. So for the fourth iteration, and as you can see, the value here is becoming really closer to the real value of square root of 2, like the value that we know from the calculator. So as always, instead of an, we put the previous value, which was over 480, and then I copy this here. So the new value is 1.4142135562, and so on. So our first value in the sequence was 1, and then we add 3/2, and then we add 17/12, and so on. And these values are getting closer and closer to the square root of 2. That's why this sequence is divergent.